Welcome everybody. I'm Vicky Bloom and I'm here today to discuss emergent AI with a focus on utility AI. Thank you for being here, especially as it's the last session of the day. I'll start with a brief overview of the session. I'll begin with a brief introduction to myself and my company, and then I'll take a high-level look at AI in games. I'll then move on to a deeper dive into utility AI in games with some specific gaming examples, some core mechanics, the theory, what is utility AI and how to use it. We'll look at an Unreal demo and I'll use plugins for rapid prototyping. I'll then wrap up with some tips and the conclusion. I'd appreciate it if you could keep your questions until the end. A quick bit about me when I'm not working. I love travel and adventure, and I've visited all 7 continents. I've had some unique stays and met some remarkable people, as well as had some superb wildlife encounters and adrenaline-filled adventures in some of the most remote places on Earth. When I'm working, I've had a very diverse tech career that has spanned over 20 years. There's been a common thread throughout all of this, which has always been software engineering. I can kind of split it into 3 distinct phases. The phase on the left was when I first entered the industry as a software engineer and worked at a range of companies. I then decided to go back to academia and did a master's in AI at Imperial, followed by a PhD in machine learning at Kingston University, and went on to lecture in games technology at Coventry University. My third phase, which I'm currently in for the last 6 years, has been making games. It's been across a range of different titles from indie to AAA, using different editors such as Unity and Unreal, and cross-platform from mobile, PC, and console. My passion is AI in games. I love bringing characters to life on screen. I want to encourage more women to get into gaming, which is why I'm both a Women in Games ambassador and a Limit Break mentor. I work for Astrid Entertainment. It's a new game and entertainment studio. We wish to inspire positive community play through exploration, connection, and wonder. You can see some concept art from our game that's currently unannounced on the screen. Our philosophy is we are better together. I'm proud to be part of a strong female leadership team, which is headed up by Sharon, our CEO, Megan, our art director, and Liz, who's with us in the audience, our production director. Now I've introduced myself, let's move on to AI in games. I'll start with a high-level overview of AI in games, looking at the differences between symbolic and machine learning, and then we'll take a deeper dive into emergent AI and focusing on utility AI. So AI in games is a huge and diverse topic. We can split it into 2 main categories of symbolic AI on the left and machine learning on the right. Those again are split down into scripted and emergent AI. This is what will be the focus of this talk. If you're more interested in machine learning, for example, generative AI, please see Tommy Thompson's talk on Thursday for a deeper dive into that. So if we look at scripted AI, it's fully designed. It has fixed transitions which are predictable and can lead to some brittle behaviours. Finite state machines is a classic example of this for Pac-Man from the 80s. So the ghost behaviours were controlled by finite state machines. We can see a simple example here where you have distinct states of the ghosts and transitions between these states. This is simple and predictable, but can become unwieldy as complexity grows. Behaviour trees became popular in the mid-2000s and were used in the Halo franchise. They are common for NPC control today, and they've been a widely adopted method. A behaviour tree is a model of plan of execution, and it's graphically represented as a tree. Behaviour trees provide a more flexible, modular, and scalable solution for complex NPC behaviours. They allow for dynamic decision-making and prioritisation of actions. However, they're still designer-driven. When we move on to looking at emergent AI, the difference is that it's fully autonomous. It separates what the AI does, its actions, from what it should do, the heuristics. The strengths of this are that it's flexible and durable, and it can produce highly dynamic and context-sensitive behaviours. Some of its weaknesses are that the designers have less control over the sequence of actions, and it can be more difficult and challenging to visualise and debug. Some examples of emergent AI are utility AI and goal-oriented action planning, or GOAP. Utility AI has been used in The Sims. It's basically where every possible action is scored at once and one of the top actions is chosen. We'll see much more details of this in this presentation. GOAP, which was popularised by Fear and has also been widely adopted since, is also based on the concept of utility, and it extends the concept to more than one action in a series. Now we've taken a look at high-level look at AI in games. Let's look at utility AI. Let's look at some specific gaming examples, the core mechanics, the theory, what it is and how to use it, and let's look at some demos in action. We see some key examples here from The Sims, Zoo Tycoon, Dragon Age Inquisition, and Alien Isolation. All of these games use utility for their AI. Let's take a look on the next slide at how they use it. The Sims is one of the most successful video franchises of all times. It's a digital dollhouse where the NPCs have mental and physical needs, which are dubbed motives. The objects in the environment broadcast what they can offer to the NPCs, and these are dubbed as advertisements. The NPCs in The Sims use utility AI to give them autonomy and so they can adapt to their environment. Their needs are translated into a happiness gain. They select the activity that can increase their happiness the most. Some of the motives in the original Sims were the hunger, hygiene, fun, energy, bladder, social, comfort, and room, or otherwise known as tidiness. These motives all have different decay rates and can decay at different rates depending on the situation, for example, if a Sim is eating food. They also have unique curves that you can see on the left-hand side of the screen. And once they have a higher happiness, it influences their lesser needs, as in the Maslow's hierarchy of needs. Another thing that they've implemented in The Sims for their utility is something called bucketing, or it's otherwise sometimes known as dual utility for the actions. This groups sets of actions together that are related. So, for example, the NPCs, they do not starve to death whilst watching TV. In The Sims 1 and 2, every Sim had the same 8 motives, and these were weighted to simulate personality, for example, playfulness. In The Sims 3 and 4, each Sim has a basic set of motives, plus they have additional motives which are based on their traits. The traits, for example, could be that they're an art lover, bookworm, foodie, geek, music lover, perfectionist, etc. But these set of motives doesn't just vary between the individuals in the game, it varies within the same individual over time. Zoo Tycoon also uses the dual utility, or the bucketing, for both its animals and guests. It uses these buckets to keep the AI generic, but also limiting the actions that are appropriate for the context, such as when a person is at a show. Dying is just another bucket that gets priority over any other bucket, so that the animal won't accidentally wake up. In Dragon Age Inquisition, the companion AI characters each have a variety of abilities, weapons, and magic attacks to help you fight. They use behaviour snippets based on utility AI to help select abilities based on the character's situation and their currently equipped ability. Alien isolation has two distinct behaviour management systems, a macro director AI, which uses utility AI, and a micro alien AI that uses behaviour trees. For the utility AI, the director AI, it's responsible for managing the menace gauge, for applying just the right amount of pressure at any one point in the game, to be able to balance the fright factor with the players being able to make progress in the game. It does this by alternating the alien's active and passive states. It also uses behaviour tree for the alien AI to manage its behaviours through a complex system of nodes, and it's able to unlock some of these behaviours progressively to simulate that it's learning. There's collaboration between these two systems, so the director AI is able to guide the alien towards the player to maintain the right levels of tension, whilst the alien independently hunts the player using its own sensors. Now we've looked at some key gaming examples using utility AI, let's take a look at the core mechanics. Let's see what utility AI is and how we can use it. In this section, our fictional character, Dolly Starfleece, who was a Bing Copilot generated NPC, both the image and the backstory. She was born in a meadow of moonflowers. Her personality is both gentle and curious. She has the power to guide lost travelers, and she loves corn and dancing in the moonlight. I'll use her to demonstrate a rapid prototyping approach to show that with even no previous experience, you can quickly and easily create an emergent NPC for your game. So what is utility AI? We briefly touched on this before. So we have a series of actions here that Dolly can perform: wander, seek, eat, guide, dance, and heal. So every possible action is scored at once. And one of the top scoring actions is chosen. The score that we see is a single value, and it's called its utility. It's the usefulness of this action within the given context. So we see here, for example, that seek has the highest score. So in this case, the simplest way is to select the highest one, but we'll look at alternative approaches as well a bit later. So how do we calculate this single utility value? We start small with a subset of actions. So I've just taken two of the actions to demonstrate this here for you today. I've taken the seek and the eat action. And we iterate. It's rare that a decision will rely on just a single piece of data. A decision factor can be thought of as a single point of consideration for a decision. The utility score is simply a combination of the decision factors. For example, you can simply average the decision factors to get a final score. So for example, if we're looking for Dolly to seek food, we can simply take the proximity to food and her hunger values and take an average of these, which gives us our seek value. Decision factors are reusable and can be used for scoring multiple actions. So we can see here that we can reuse our hunger decision factor, and we can also introduce another decision factor, whether Dolly has previously found food or not. And we can combine, these decision factors can be combined in different ways. So we already saw that we had the average before, but we can multiply these as well. Multiplication becomes really useful when you want to exclude specific actions when specific conditions are not met. So in this case, Dolly will never be able to eat food, no matter how hungry she is, if she hasn't previously found the food. So if we multiply the found food 0 by any of the other decision factors, we're always going to get the result of 0, which is what we want in this case. So now we've seen how we combine our decision factors to get our final score. But how do we actually score the decision factors themselves? We can use one or more game state values and some maths, which can be visualized as curves to get to these values. We'll look at curves in more detail on the next slide. Once we have our decision factors, we can also apply further modifications such as weights that can determine how much an NPC cares about that particular factor, which can be used to emulate different personalities. So when we look at our utility scoring, our curves are how we take an arbitrary gain value or state and convert it into a utility score. This can be highly subjective, and it's the key to utility theory is to understand this relationship between the input and the output and being able to describe it as a curve. The curves are how we go from the gain value to its utility value. A curve is a graphical representation of the solutions to a function. This becomes more of an art than the science, and it can take most of the time. Let's take a look at some examples. We'll start with a very simple example, which is a linear curve, or it's called a normalization function. So if, for example, Dolly has eaten 10 pieces of corn and her tummy could hold 100 pieces at one time, her fullness could be expressed as this linear curve that we see here. If we wanted to inverse this function and actually we wanted to calculate how hungry Dolly is instead of how full, we can simply just invert the function or invert the curve. This is okay, but it's not realistic as hunger is not linear. We get hungry slowly and then suddenly we're starving. So we can use different mathematic functions to model things more precisely. For example, we can use quadratic curves that start slow and then curve upward. As the value of k rises, the steepness of the curve also rises. We can also invert these curves as we did previously and have a mirror effect and model hunger rather than fullness. We can use these curves to model Dolly's hunger, so she gets a bit hungry slowly and then she suddenly feels starving. You can use mathematic formula to generate your curve, but sometimes this is just not enough. Sometimes designers need to be able to fine-tune the specific outputs based on the inputs. The solution is custom curves, or sometimes called piecewise curves. So a piecewise linear curve is simply a custom curve that you hand-tune the two-dimensional points to the exact locations that you want, and in between, the data is interpolated. So the previous curve was modeling hunger quite well, but there was still the chance that Dolly would choose to eat when she was nearly full. The chance is small, but it could get chosen. So using a piecewise linear curve, designers can completely ignore hunger until it reaches a specific threshold. She can then get a little bit hungry and suddenly very hungry. We touched on scoring earlier, so how do we pick an action? The simplest would be to simply select the highest scoring. So from these actions, we would simply select the seek, being the highest score. But this can feel robotic. So there are alternative solutions. We can use the utilities as weights and choose randomly. This behaves well most of the time, but sometimes the NPC can act really stupidly. We can also take a subset of the highest and choose with a weighted random. For example, we could take the top 5 actions, or we could take within a percentage range of the top score, say 10%. Generally, these approaches work well, but sometimes there can be inappropriate actions. And this is where we could look at the bucketing that we mentioned earlier. So bucketing, or sometimes called dual utility, groups sets of actions together. These actions are categorized into something called buckets, and the buckets themselves are weighted or use priority score with utility. Then the highest priority bucket is processed first. So in this example, we've grouped Dolly's actions into 2 buckets, a hunger bucket and a social bucket. So the buckets would be scored first, and the hunger bucket, as it has the highest score, would be all the actions in this bucket would be processed first. And if we find a matching action in this bucket, this would be the action that would be selected. Only if we could find no matching actions in this bucket would we then go on to process other buckets. I can see I've made a small typo here. This is meant to say oscillation. So the potential issue with any AI system is oscillation, with the system deciding to do a different action every frame, which can look very bad. Some solutions that we propose for utility AI is we could weight the current action to give it higher priority. We could use cooldown so that we don't jump from one action to another straight away. Or we could have a threshold, which we have to surpass to switch to another action. So now we've looked at the theory of utility AI. Let's take a look at an Unreal demo. And we'll continue using Dolly as our guide. So I just want to say that I'm not affiliated with this plugin or any of the other products that I'm going to reference in my talk. But a good plugin gives a quick start to implementing your AI. They often come with more than the basic algorithms, such as visual debugging tools. This next section is a deep dive into utility AI and will focus on Unreal. But plugins are also available for Unity, and code is available for C++, which you can use with other engines. They're also available in other languages as well. These have many of the same features that I will show you next. So what you will learn, even if you're not using Unreal right now, will be transferable. And I will provide links at the end to these alternative solutions. So the plugin that I've used for this demo is from the Unreal Marketplace. It's the Easy Utility AI. It has some key features that it can support multiple actions that run in parallel. It works with the Unreal Curve editor. It has custom query and blackboard system, as well as a visual AI debugging tool. It's implemented in C++, and it has Blueprint for easy access. I'm going to show you some videos. Here is the prototype in action. So this is just a quick prototype that I created for this talk from scratch, which just took a couple of hours, just to demonstrate utility AI and how we can rapidly prototype. I used the blockout world for the characters for speed of iteration. I also used blockout characters, which cuts out the fuss of models and animations. And you can always use emojis or text if you want to give them expressions. You can see that I've cloned Dolly, and I keep track of how much food each Dolly has eaten, which diminishes over time to stimulate digestion. She starts with a full belly. I use the AI debugger that comes with the plugin that you can see on the left-hand side of the screen, which is an actor that visualizes the scores of each of our NPCs in real time. And it shows the NPC that currently has the arrow above its head. And you can use the mouse wheel to scroll through and look at any of your NPCs as they're executing actions, which really helps with debugging and understanding what's going on. For the project setup, if you already have a game, you can use that, or you can simply create a new one. You can, in Unreal, you can use the templates, for example, the third-person template, if you want to quickly get a C++ project set up with a player character. You'll need to install a utility AI plugin, or you can, for example, import source code or write your own algorithm. You can use an Unreal example map, or you could create your own. And you could use the Unreal example characters or create your own. You'll need to add some elements in your environment for the character to interact with. And if you want your NPC to move, you'll need to add a nav mesh bounds volume to your map. If we take a look now at the NPC setup, for each NPC in Unreal, you need both a character and an AI controller to get started. I use the basic character class as the parent class for Dolly. I use the detour crowd controller as it has basic avoidance of dynamic obstacles for the controller, which inherits from the basic AI controller, which you also can use. For Dolly to be able to sense items in the environment, we can use the Unreal perception system, or there's alternatives such as the pawn sensing system in Unreal. This example, we've used the perception system. It's very easy to use. You can just add the AI perception component listener to our NPC controller. And then you can add the senses that you're interested in perceiving. So in Unreal, there's built-in senses such as damage, hearing, prediction, sight, team, and touch, or you can even extend this and make your own senses. We've used sight for this demo. You can also set more than one sense, and then you can set which is the dominant sense. So this, we've kept it simple, just use one in this case. You also need to make sure you add the AI perception stimuli source. So that's the part that goes on the object you're interested in, which in our case would be the corn, so that we can sense it once we're running the game. If we look at the food setup, so this is simply just an actor in our environment, and Dolly loves corn, so that's what we've added here. I've used a billboard, so that's just a 2D texture that's always facing the camera, again, just for quick prototyping instead of having to create or find 3D objects. It's much faster. Now we'll look at some more details of the Easy Utility AI plugin in Unreal. There's 4 main elements. There's the task manager, tasks, queries, and curves. And at the end of this series of videos, we'll see it all put together. So our task manager, it inherits from the Easy AI task manager. And this is the thing that controls our tasks or actions. And it's added to our AI controller. We can see here that it's actually all of the actions that we want to perform for Dolly. So we have here, for example, the wander, the seek, eat, guide, and dance. And so this is where you tell which are the available actions for your NPC. And these are all scored at once, and the highest scoring action is selected. So that's our task manager. We'll next move on to look at the tasks themselves. So for each action, you need to have a task, and each task has 3 main events. It has a scoring, action, and a cleanup. So if we go into our tasks folder, you can see all of our tasks here for Dolly, and we'll take a look now at the wander task. This is one of the simplest tasks because we haven't implemented a scoring action. We've just given it a default score on the right-hand side of the screen. So this action will run when no other action is scored above 0.1. So it's kind of like our default action. So we can see here, I'm going to make this a little bit larger so I can see it better. We can see here that this is the start event is when our task, when this is the highest scoring task, so no other tasks have been scored, this is what the behavior that we'll perform. So we pick a random point within the radius of our character, we rotate towards it, and then we move towards that point. Either if we're successful or we fail, we stop the movement. And if we're successful, we have a cooldown, so we wait again. We wait a small period of time before we move on and repeat this action. So next, after the task, is the queries. We can use the queries to find actors, location, or navigation in the environment. You can either reuse an example query that comes with the plugin, or you can create your own. We'll take a look now at the food query we've used. So each query has 2 main methods that you need to override, the get actors and the get scorers. So the get actors needs to get all the actors that are going to take part in this query. This is very easy if you're using the perception system because we can just grab the perception component on our querier and we can check all currently perceived actors. So this will get a list of all things that are currently in our sight range, and we define those parameters in our setup of the distance, for example, of how far we can see. So this will just simply return a set of actors. Once we have this set of actors, we use the get scorer method on each of these actors to give an appropriate score. Here we can see these make utility scores, and these are equivalent to the decision factors that we discussed earlier. So each decision factor can take a condition, an input, a base value, and a curve. So for example, if we want to look for all actors that are closer than 2,000 units, we can simply get the distance between our actor and our NPC. And we've actually used the inverted curve to prioritize the items that are closest to us. We can see here that in this array, we're combining multiple decision factors or utility scores. And we can see on the class defaults here how these are scored. So we can switch between the default, where the scores are multiplied, the average, or a balanced approach, which again uses multiplied, but it has a compensation factor depending on the number of scores that you have. We can see here an example at the bottom where we just have a condition. So we're checking, is the thing we sensed of the type corn? This will give us either a 0 or a 1 value. And then because we use the multiply, this will then ripple up and either give us a 0 or the number that we have, obviously, based on distance. So this will give us the score for whether we can, how valuable this item of food is to Dolly at this point in the game. And finally, we have our curves. So curves is one of the inputs to our decision factors or our utility score, and it can be selected from existing assets, or you can create new ones. The inverted curve, which we saw, the linear curve, comes with the Easy Utility AI plugin, so it can be found in the content folder. But Unreal has its own curve editor that's quite often used for animations, but can also be used to create these curves. I'll provide a link at the end of a tutorial on how to use the editor to make curves in Unreal. We can also see some examples of function curves here. And an example of a simple piecewise linear curve. Other plugins that I saw, for example, the Unity plugin that I saw also came with its own curve editor, so you'll be able to do a similar thing in Unity as well. Okay, so let's put all of this together. Let's take a look at our seek action. So our seek action in the begin play, which is just run once, this does the setup and sets up our food query that we looked at earlier. The update event is which runs at 0.1 every 0.1 seconds. That's a parameter you can set, and this is what does our scoring to give each action a score. We use here something else that comes with the Utility AI plugin. It's kind of like a blackboard value, these runtime keys. They use gameplay tags, and you can store values against tags, which is really useful because they're shared between different parts of the AI. We can see here on the right that we set our utility score. In this case, we just got one value. That's whether we've, the food value, that how much food that Dolly has eaten. And again, we use the inverted curve here to take it from fullness to hunger. So we measure how hungry she is. Now, if this was the highest scoring action. In the start event, this is only called when this action basically is the winning action. We check some parameters here at the start, and then once we're satisfied this is an item that we can move towards, we rotate towards it and move towards our target. Once we get there, if we've succeeded, if that was a successful movement, we store that item of food so that we know we can eat that. If not, we just clear the blackboard values or our runtime keys. I wanted to give a shout out to another plugin, which is Blueprint Assist. That if you're using blueprints a lot, it really, really makes your blueprints a lot clearer and you can iterate much faster. You simply either can have it on by default or you can use a shortcut key and it basically aligns all your arrows and nodes and it makes it much less spaghetti-like. So if you haven't tried that out, I'm giving a shout out to that as well. Okay, now we've had a deep dive into utility AI. Let's wrap up with some tips and some strategies, and I'll conclude with my thoughts. So, tips to get started with utility AI. Understand the basics. Hopefully this presentation will give you a better understanding, and there are lots more resources available at the end of this presentation for a deeper dive. Define your actions and decision factors. Clearly define what actions your NPC will perform and what utility functions or decision factors that you will need to evaluate the desirability of these different actions. Start simple and iterate. Begin with a basic utility system that just evaluates a few key factors. This will aid your understanding and allow you to test and refine your approach. Balance your utility values. Normalize your utility values so that they can be compared fairly. You can also use weights for decision factors based on their importance. Finally, make sure you test and optimize. Unreal has functional tests with AI support that are great for automated testing. And you can check your performance metrics by using things like Unreal's insights to profile and identify any bottlenecks in your implementation. So these are just some challenges that I've had to overcome and some strategies that I've tried or will be trying in the future. So one of the big challenges for me was that this works great for atomic actions, but it doesn't readily support sequences of actions. So what you can do in this case is you can gate your actions with global state variables. It kind of is easy to implement, but is kind of a little bit on the crude side. A more sophisticated approach would be to start combining utility AI with other systems. So for example, utility and AI and behaviour trees, like we saw earlier. Another challenge that I've come across is working with utility AI is it's not as well known or as supported as behaviour trees in the editor. This means that you need training and knowledge sharing within your team to get the most out of this system and to look at creating custom tools for your designers so it's easy for them to create these characters and iterate upon them. Utility scoring is lightweight, but performance can be an issue in large open worlds. So some of the solutions are to have an early return, check the simple conditions first, and return if these conditions are not met. There's no need to score all the possible outcomes if you're literally going to, reject it anyway. Bucketing or dual utility that we looked at earlier, because this is hierarchical, you only need to score the bucket at the bucket level, and then the actions in the bucket. So if you have lots and lots of actions, obviously this can dramatically decrease the amount of scoring that you need to do. You can do this at level of detail. So you could only score a subset of the critical actions when the NPC is out of range. For example, in The Sims, they have this low LOD Sims performing only the long-term life actions when they're out of range. So for example, they could get married, have children, move home, but they don't need to be eating, drinking, etc. when you're across the other side of the world. And the final solution is aggregate. You can actually model the whole town or a village instead of the individuals. So for example, in The Sims, each town has its own desires and is scored like the characters. And it has, for example, it has a gender ratio that it likes to maintain. So, in conclusion, utility AI is a powerful way to get rich, lifelike behaviour out of your NPCs. One of the great appeals of this system is the amount of emergent behaviour you can get with a few simple values and a handful of weights. By combining decision factors in meaningful ways, you can build up decisions from these atomic components to provide very deep AI. It's easy to set up and iterate, so why don't you give it a try? I won't go through the resources now, but you'll be able to get a copy of this presentation. You'll be able to download it after the event. So I've put 2 pages of theory, and then there's some practical links as well. So I've covered both the Unreal, all the Unreal resources that I've listed here I have used, and I have used them on real projects, and I can really say that they are really fantastic to use. The others, I haven't actually used in person, so I've looked them up. The reviews look good, but please take with caution and do your own investigation into those before using them. So thanks for listening. I appreciate you giving me your time to be here. Please feel free to ask me any questions now or catch up with me afterwards. I'll also be heading to the icebreaker after if you want to catch up with me there, and you're free to come chat with me. I've only just seen the really cute dog there. Yeah, I've got a question over there.
Thanks for the talk. Actually, I worked on alien isolation AI, so thanks for the shout out. Can you repeat the question?
Yeah. Hello.
Hi.
Actually, I worked on the alien isolation AI, so thanks for the shout out there. Okay. And we did use the utility AI and the behavior trees combined for the alien AI for that. My question is actually with you mentioned that the hardest part, the most sort of time-consuming part is the curves and tweaking the right balance between all those curves. Have you considered using, say, some sort of ML, machine learning or optimization methods to actually learn that from like the desired tasks rather than having to fiddle with lots and lots of curves?
That's a great question. Thank you. And thank you. I might be picking your brain for more ideas later. So no, we haven't looked into machine learning for it, but it's definitely, obviously, a possibility and something I would like to look into after this talk. So thank you for your suggestion. Any other questions? Okay, have a great evening, everybody.